So guys, next we will going to discuss an end-to-end example of layer 3 routing. So in this example, we have a 4-node topology. This 4-node topology contains 4 routers. The router names are VM, VM1, VM2 and VM3. In this example, we will going to see that how the packet is routed from the source router VM to the destination router VM3. So we will see that what is the role of intermediate routers VM1 and VM2 and how the intermediate routers take their decision in order to route a packet in the correct direction so that the packet eventually reach its intended destination. You can see on the left hand side we have a L3 routing table. So this is the L3 routing table entries for all the routers shown in the topology. These L3 routing table entries are populated in a way such that every router in the topology is reachable or pingable from every other router in the topology. Now you already know the semantics of L3 routing table entry, so I expect you to go through this routing table and understand that how every router in the topology is reachable from every other router in the topology. You can also see small boxes against each router in the diagram. These small boxes denotes ARP table. So you can see that, for example, for virtual machine VM1, there are 2 entries in the ARP table. The number of entries in the ARP table is equal to the number of neighbors of a router. So it is for this reason that for router VM1 and router VM2, there are 2 entries in the ARP table of these virtual machines. So as we know, the ARP table contains the mapping of an IP address to MAC address for a neighbor. So our problem statement is that from virtual machine VM, which is our source machine, we want to send a data packet to destination IP address 192.168.5.2, which is the IP address of local interface of virtual machine VM3. And how L3 routing makes the packet journey possible from source machine to destination machine in the layer 3 network. So in the step 1, VM wants to send a data packet to destination IP address 192.168.5.2. VM checks if the destination IP address resides to one of its local subnet. In this case, the destination IP address belongs to the remote subnet. So in step 2, as soon as the router comes to know that the destination IP address belongs to the remote subnet and not local subnet, the next thing that the router VM does is to look up its L3 routing table. So in this lookup, the router VM tries to find a matching entry which matches the destination IP address 192.168.5.2. So in this example, the entry number 1 of router VM will be picked up. So in step 3, using this matching entry, the router VM now knows that it has to send the data packet out of interface Ethernet 2 towards the gateway 192.168.4.1. That is this gateway. Now, after step 3, the job of layer 3 routing is done. Now, the next thing that the router has to do is to know the MAC address of the gateway to which it has to forward the packet. So, in step 4, router, that is VM, now look up its ARP table using IP address of the next hop, that is gateway, as a key. So, the gateway is 192.168.4.1 and it finds that there is a MAC address for this IP address in its ARP table. So this MAC address, let's say, is MB. So at this point of time, the router VM knows that the source MAC address will be the MAC address of outgoing interface, which is Ethernet 2. The destination MAC address will be the MAC address of the gateway, which is MB. So source MAC address is known, destination MAC address is known, source IP address is already the IP address of the current router VM, and and destination IP address is an input from the user, which is this IP address. So now the information regarding all these four fields, that is source MAC, destination MAC, source IP and destination IP, is known. So the router now is in a position to actually prepare a packet. So VM now prepares a packet, and following is the packet content. The source MAC address, as you know, the MAC address of the outgoing interface, which is MA. The destination MAC address will be MB. The source IP address will be taken as the IP address of the outgoing interface, and of course the destination IP address is the user input. So this is how the router VM actually prepares the packet and ships this packet on the wire. So going forward, VM1 receives the packet. Ethernet layer of router VM1 checks if destination MAC address in the packet is equal to MAC address of the receiving interface. As in this example, it is true. So the data link layer or Ethernet layer on virtual machine VM1 chop off the Ethernet header and hand over the rest of the packet to the layer operating on the top of data link layer, that is network layer. Now what does network layer do? The network layer on virtual machine VM1 checks whether the destination IP address in the IP header of the packet belongs to any of its local subnet. In this case, no. Right? So VM1 checks its routing table and search for a destination subnet which hosts this destination IP address. In this case, the entry number 1 of router VM1 is picked up, that is this entry. So now the router VM1 also knows that it has to send the packet towards the gateway 192.168.1.2, and the outgoing local interface is Ethernet 3. So the network layer of the router VM1 has decided that where to forward the packet to. So again, VM1 will do the same thing. It will now look up its ARP table using next hop IP address 192.168.1.2 as a key to know the next hop MAC address, and we know that the next hop MAC address will be MD. So remember, if the router VM1 did not have this information that the next hop MAC address is MD, then it would have launched ARP broadcast request. But here we have assumed that all the routers in the topology already have ARP table populated, so we make our discussion simple by not discussing ARP complexity here. So VM1 now prepares the packet and sends the packet out of interface Ethernet 3. So what will the packet content now? So the packet content will be that source MAC address will be MC, the destination MAC address will be MD, and the source and destination IP address will stay unchanged. So you can see that whenever the router forwards the packet, the source MAC address and the destination MAC address in the packet keeps on changing. So going forward, our packet has now reached to router VM2. So VM2 receives the packet. The Ethernet layer checks if destination MAC address in the packet is equal to the MAC address of receiving interface. So in this example, it is yes. So the router does the same thing. It chops off the Ethernet header and hand over the rest of the packet to the network layer. The network layer of router VM2 checks whether destination IP address in the packet belongs to any of its local subnet. Now in this case, it will be true because the destination IP address in the packet is 192.168.5.2, which belongs to the local subnet 192.168.5.1/24, and this is a local subnet to router VM2. So destination IP address in the packet belongs to subnet 3, which is a local subnet for router VM2. It means that the packet has now reached its intended remote subnet. Now VM2 will deliver the packet to VM3 using L3 routing only. Now note here that the destination IP address in the packet belongs to a local subnet to router VM2. This is one case. But the destination IP address in the packet do not exactly matches with the IP address of any local interface of router VM2. This is second case. So in the second case, when the destination IP address of the packet falls in the local subnet of a router but do not exactly matches with the IP address of any local interface of a router VM2, then the router decides to forward the packet further using L2 routing only. When the destination IP address of the packet falls in the local subnet, but it do not exactly matches with the IP address of any local interface of a router, the router concludes that the packet is intended to reach a final destination machine which is present to its one of the local subnet. So here you can see that the router VM2 now concludes that the packet is destined to a machine which is present on its local subnet, subnet 3. So now VM2 will deliver the packet to VM3 using L2 routing only. So VM2 now look up its ARP table using destination IP address 192.168.5.2 as a key to know the next hop MAC address, which is MF. That is this MAC address. So VM2 now prepares the packet and sends the packet out of interface Ethernet 2. That is, VM2 can now send a packet out of this local interface. So the contents of the packet at this point of time will be that the source MAC address will be ME, that is the MAC address of the leaving interface. The destination MAC address will be the MAC address of the next hop, and the source and destination IP address remains unchanged. Now at this point of time, our packet has reached to router VM3. So VM3 receives the packet. Ethernet layer checks if destination MAC address is equal to the MAC address of the receiving interface, and it is yes. So again the Ethernet layer chops off the Ethernet header and hand over the packet to the network layer running on virtual machine VM3. So VM3 network layer checks that the destination IP address in the packet belongs to any of its local subnet. Now in this case, of course, the destination IP address in the packet falls in the subnet 3, and subnet 3 is a local subnet for router VM3 as well. So in this case, yes, the destination IP address belongs to subnet 3. So router VM3 now knows that the packet is destined to the local subnet. Now VM3 also checks that whether the destination IP address in the packet exactly matches to the IP address of one of its local interface. Now in this case, the destination IP address in the packet matches with the IP address of the interface Ethernet 2. So VM3 now knows that the packet was destined to itself. So VM3 chops off the network layer header and delivers the rest of the packet to the transport layer. So the transport layer finally processes the packet and delivers the packet to the application layer. And because this router, that is router VM3, is an ultimate destination of the packet, it do not forwards this packet any further. So there is no point of discussing the contents of the packet here. So you can see that this is how the layer 3 routing happens from source machine to destination machine. The layer 2 and layer 3 routing plays their respective roles in order to take the packet from one router to the next router, and then from the next router to again to the next router, and so on. So in this example, layer 2 routing was responsible in order to take the packet from current router to its neighbor router, whereas layer 3 routing is responsible to decide that which is the next hop router which the current router should send the packet to. So I hope the concept of layer 3 routing is crystal clear with this example. There is one more example which I found on the YouTube, and this is the best video that I could find on the internet which explain the concept of layer 2 routing and layer 3 routing in pretty much detail. So this is another example that you can follow, or you must follow, in order to understand the concept of layer 2 and layer 3 routing. It is very important from the interview's point of view that you will be straight away asked by the interviewer to explain the entire L2 and L3 routing concept, which is no different than what I have explained in this lecture video. And of course you should visit this YouTube link and try to grasp the idea. This video explains that how layer 2 ARP table and layer 3 routing tables are populated, and also it explains that how these tables are used in order to route the packet from source machine to destination machine. So I request you to watch this YouTube video again and again until you can explain the concept of L2 and L3 routing to your friend on your fingertips. So that's all about routing. Thank you.